Hello students, and welcome to the third part of electronics fuel injection system. Myself Shankhu Ghosh, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandra Sood Degree Engineering College under JIS Group. Today we will discuss on the third part of the electronic fuel injection system of the module number 3. The module number 3 is known as vehicle operation and control. This topic under the subject of the modern vehicle technology. This is the 7th semester syllabus of automobile engineering students. The subject code is AUE 704B. In the previous classes, we'll discuss about the electronic fuel injection system, conventional fuel supply system of petrol engine and diesel engine, the differences of carburetor and injectors. Besides this, we'll learn about the fuel injection system, its applications, advantages, disadvantages. Then we study the various types of fuel injection system. Today we'll discuss about the CRDI, which is the another type of electronic fuel injection system. So students, the objective of today's class is to understand about the CRDI technology or system. So student, let's start the today's class, that is third part of electronic fuel injection system. CRDI or common rail direct injection. It is used especially in the diesel engine for the better performance and the good efficiency. The concept of common rail injection first began in Japan in the middle of 1990s under the Denso Court. After extensive research by the Fiat Group, the final design was acquired by the German group Bosch for the mass production. In CRDI, the fuel system components are more intelligent, which are controlled electrically. The traditional injectors are replaced with advanced electrically operated solenoid injectors. Injectors are open with an ECU or engine control unit. Signal depending upon the variables such as engine speed, load, engine temperature, and etc. In CRDI or common rail direct injection, there is a common line which is called common rail, and each injector is connected to this line. So in the CRDI there is a common line which is known as the common rail, and each injector is directly connected with this line. Through this line, fuel sent into the cylinder. In conventional diesel engines, the pressure needs to be readjusted. The pressure needs to be readjusted for each injection process. While in CRDI, the pressure is always constant. While in CRDI, pressure is always constant. And this pressure remain constant along the fuel line. This pressure remains constant along the fuel line. The ECU adjusts the injection timing of the injectors depending on the engine load and engine speed. The amount of fuel to be delivered to the combustion chamber is set by the ECU with the information which is provided by the sensor in the engine. Fuel is supplied to the combustion chamber when it is needed. The fuel is not sent to the combustion chamber when it is not needed. This saves fuel and reduces the emission. As mentioned before, fuel measured more accurately in CRDI technology. That's why the amount of unburned fuel is significantly reduced. After the combustion stage and the Euro 5 emission standard achieved. History. The common rail system prototype. The common rail system prototype was developed by Robert Hoover and Dr. Marco Ganser at the Swiss Federal Institute of Technology in the late 1960s. But the first successful use of this technology accomplished by Japan in the 1990s. For the first time, this technology was used on heavy vehicle and later adapted to automobiles and passed to the mass production. Now coming to the working principle. Here is the picture of the MPFI. This is the cam block. Then this one is the follower, push rod. This is the rocker arm. Here is the lever. Is the spring. It's a nozzle valve seat. Here is the accumulator, and there is a high pressure relief valve and the high pressure pump. This is the fuel tank. So here the high pressure pump, a high pressure pump is used to supply fuel to the accumulator or the heater from the fuel tank. In case pressure in the accumulator increases beyond the limit, the high pressure relief valve which is connected to the accumulator helps to reduce the pressure. Now this fuel from the accumulator supplied to engine cylinder using the fuel line with the help of solid injectors. Another spring-loaded high pressure relief valve used to maintain the constant pressure in the system for the smooth operation. Sorry. It also returns the extra fuel of the accumulator to the fuel tank. In the diagram, you can see the needle valve. It is used to control an opening and closing the nozzle while it sprays the fuel into the cylinder. The upward and downward motion of the nozzle, is measured by the cam. Cam is connected to the spring. The cam is connected to the spring with the help of rocker arm and the lever. During the dual period of cam, spring with the help of needle valve prevents the injection of the fuel into the cylinder. The packing gland ensure the level of the fuel above the valve seat for better injection of the fuel into the cylinder. The wedge plays the main role in this system. It controls the amount of fuel to be injected into the cylinder in accordance with the power required for the engine. The wedge is operated by the governor, or it can be operated manually as per the requirement. Now coming to the features of CRDI technology. The emission problem has always been a problem. For ships, train, heavy duty vehicles, generators and other vehicles with the diesel engines. Another important problem was that customers were constantly looking for economical engine with lower fuel consumption. The emission problem was solved by diesel particle filter and the catalytic converter. But this time, this system were causing problem with the large space requirement. To cope with this problem, a few changes to be made in the diesel engine. Because of this, the engineers decided to develop an internal combustion diesel engine. It is known that the fuel must be burned completely to get the high efficiency. The NOx level also decreases when the fuel is completely burned, but at low speed it is almost impossible to burn the fuel completely. To achieve this, multiple injection was developed. Generally, the multiple injection consists of 5 steps, such as pilot injection, pre-injection, main injection, after injection and the post-injection. In the first stage, the pilot injection occurs immediately before the ignition. The pilot injection occurs immediately just before the ignition. It allows the fuel and air to mix properly. In second stage, pre-ignition occurs and it is reducing ignition delay before the main injection. It reduces the ignition delay reduce ignition delay before the main injection. NOx level, noise and vibration are reduced at this stage. The heat generated by the pre-injection is much higher than the heat required for the fuel itself to ignite. In this case, when the main injection takes place, as third stage, the yield from the fuel becomes higher. In the fourth stage, after the injection takes place, the unburned fuel is burned. And finally, post-injection helps the generate heat which is required by the catalytic converter. In this way, the catalyst converter works more efficiently. According to Denso data's 1800 bar common rail system increases engine torque up to 35%, engine power up to 24%, and low ideal noise decreases 6.5 decibel down on a 2.0 liter diesel engine as compared with the Denso's conventional model. Compared to the diesel and the gasoline, diesel fuel is less qualified. Compared to the diesel and the gasoline, diesel fuel is less qualified and denser than the gasoline. So it is difficult to atomize the diesel fuel. In order to get better atomized diesel fuel must be injected with a high pressure. For this reason, CRDI technology has a high pressure fuel pump. This pressure is maintained even if the vehicle is at ideal position. That is why the fuel is injected quickly when the injectors are open. CRDI improves automation as well as shortens injection time. The problem with all diesel knuckle is also reduced. Now coming to the components of the CRDI. There are the 7 components of this CRDI that are high pressure fuel pump. Second is fuel metering control valve. High pressure regulator valve. High pressure accumulator. Fuel pressure sensor, rail pressure limiter valve, and the fuel injectors. So let's start with this high pressure fuel pump. The high pressure fuel pump is located between the low pressure and high pressure pipe. The high pressure fuel pump is located in between the low pressure and high pressure pipe. The basic function is to transmit the fuel to the system at the required pressure. So the basic function of this high pressure fuel pump is to transmit the fuel to the system at the required pressure. The high pressure fuel pump is supplied by electric. This pump produces the fuel pressure. This pump produces the fuel pressure required for the high pressure injector to provide ideal mixing of the fuel and air directly into the combustion chamber. Some systems also have a transfer pump with an electric pump. Next is fuel metering control valve. It is located the backside of high pressure fuel pump. It controls amount of the fuel and it is controlled by the ECU or the electronic control unit. When there is no energy on solenoid, valve is open and low volume of fuel charging to the high pressure fuel pump. When there is energy on solenoid, the valve is closed and high volume of fuel charging to the high pressure fuel pump. This is the picture of the fuel metering control. Next is high pressure regulator valve. It controls the high pressure fuel which is delivered to the common rail. It sends the excess fuel into the fuel tank and it cool downs the fuel before send it to the tank. So after the high pressure fuel pump, it control this pressure the pressure regulator valve control the high pressure fuel which is delivered to the common rail and it sends the excess fuel to the fuel tank after cool downs the fuel. So this is the high pressure regulator valve. Next is high pressure accumulator. The fuel is sent to the common rail at high pressure. The fuel is sent to the common rail at high pressure. The fuel is stored here and distributed by injection. Fuel is stored here and distributed by the injection. In addition, common rail or this high pressure accumulator eliminates vibration caused by the high pressure pump. So this high pressure accumulator is known as the common rail. Next is the fuel pressure sensor. Fuel pressure sensor is located on the fuel rail. It measures the fuel pressure. On the common rail and communicates with the engine computer. So this fuel pressure sensor is connected with the common rail and it helps to measure the fuel pressure, means what is the pressure of the fuel which is stored inside the common rail. So this is the fuel pressure sensor. Next is rail pressure limiter valve. It is located on the fuel rail. It is located on the fuel rail. If there is generated excessive amount of pressure is if there is generated excessive amount of pressure, that pressure relieved by the rail pressure limiter valve and excessive fuel sent back to the fuel tank. So this rail pressure limiter valve is located on the fuel rail. If there is generated excessive amount of pressure, then this valve helps to release the pressure and maintain the fuel pressure inside the common rail by passing the fuel back to the fuel tank. Next is the fuel injector. The fuel injectors are controlled. By the solenoid and piezo actuators. Excess fuel is returned to the fuel depot by the injector's piston. And the excess fuel is returned to the fuel depot by the injector's piston. Piezo injectors are 4 times faster. Piezo injectors are 4 times faster than the solenoid injectors due to their fast response time. So this is the part of the CRDI engine. Now we'll discuss about the advantages and the disadvantages of this CRDI or common rail direct injection system. The advantages are higher fuel injection pressure and a better atomization provide. Injection pressure created independently from engine speed. A multiple injection for each cylinder is possible. 25% and more power, engine power and torque increased. Lower the vibration and the noise level. Lower the fuel consumption and lower the emissions level. So these are the advantages of after using the CRDI technology. Next is disadvantage. High cost engine. It requires the high maintenance, so that's why the cost is increased, as the spare parts are so much expensive. These are the 3 limitation or the disadvantage of this CRDI technology. Now come to the differences in between DI and IDI, where DI means the direct injection and IDI means indirect injection. Direct injection means injection pressure is higher 21 kg per centimeter square. In this case, as compared to the IDI, it means indirect injection, because fuel atomized is slowly depend upon the pressure. The fuel atomization is slowly depend upon the pressure of the injection. This type of engines are very easy to start in the cold also. The fuel injection nozzle have multiple hole. The fuel injection nozzle have the multiple hole as high atomization and mixing is required because swirling of air is less in this case. Thermal efficiency is higher as compared to the indirect ignition engine. Thermal efficiency is higher as compared to the indirect ignition engine. Next is indirect injection or IDI. The injection pressure is low. The injection pressure is low as compared to the direct ignition, as most atomizing is achieved using the pressure of air from pre-combustion chamber. Glow plug is required to start the engine in the cold start. Glow plug is required to start the engine in cold start. Single orifice nozzle is used here. A single orifice nozzle is used here. Heat losses are more due to the large area, so thermal efficiency get reduced as compared to the direct ignition. High compression ratio is possible. High compression ratio is possible in indirect ignition indirect injection as compared to the direct injection. Here is the acronyms of the CRDI. Means the various companies and the CRDI known as a different things, but the technology are the same. That is, for the Mercedes-Benz, this is known as CDI. In the Hyundai, is known as CRDI. For the BMW and the Volvo company, this is known as the D. For the Fiat, it is JTD. For Tata, it is CR4. For the Renault, it is DCI. For the Chevrolet, it is VCDI. For the Volkswagen, it is TDI. For Ford, it is TDCI. For the Honda, it is IDTEC or VTEC. And for the Toyota, it is D4D. So students, from this today's class, we learned about the CRDI technology, its working principles, its components, and its acronyms, its advantages and its disadvantages. So students, in this electronic fuel injection system, which is covered today. So after completed this, we learned about the electronic fuel ignition system, its various types. We also learned about the conventional petrol and diesel engine fuel supply, differences in between carburetor and the injectors, which we covered the various type of electronic fuel different types of fuel injection system. They elaborately describe the MPFI and the CRDI technology. So student, this is cover the fuel injection system. From the next class, we'll discuss on another topic. So still then, stay at home and stay safe. Thank you. Thank you so much, students.